Hi everyone, in this video we will be talking about gravimetric analysis. Now, what is gravimetry? In chemistry, any method that uses mass measurements to quantify an analyte is under gravimetry. Measuring mass is the most fundamental of all analytical measurements, and gravimetry is unquestionably the oldest analytical technique. Bago pa magkaroon ng periodic table and a definite list of molar masses, nag-e-exist na ang concept ng gravimetry. Especially in the 18th or 19th century, that was the time when metallurgy was the main interest of chemists, and they used this to analyze ores. So even though gravimetry is not as widely used today because there are faster analytical methods available, it is still good to start with the basics before going to other complex analytical techniques. I'll cite a few situations that use gravimetric analyses. So one application is in determining the total suspended solids in a water sample. So you just dry it, weigh the solids, and from there you can report na ito na yung total suspended solids na na-measure. Another example is determining the moisture content of food. To do this, we can heat the sample of the food to a particular temperature para mag-dry. Whatever is the difference in the mass before and after heating, that is now your moisture content. What if ang analyte is an aqueous ion such as Pb2+? In this case, we cannot isolate the analyte by filtration. Lulusot lang siya sa filter kasi dissolved siya sa water. So, what scientists do is to convert it into a solid by means of a chemical reaction. In this case, pwede gamitan ng electrolysis and we can now get the solid lead oxide in the products. Another example is measuring phosphite in a sample. Phosphite is known to participate in this reaction as shown. And in the end, what you are going to measure is the mass of the solid product, Hg2Cl2. Then using stoichiometry from there, you can calculate the amount of the phosphite that you started with. The examples I've mentioned here fall under the different types of gravimetry methods, specifically particulate gravimetry, wherein the mass of the analyte is determined following its separation from the matrix, volatilization gravimetry, wherein the loss of a volatile species gives rise to the signal, electrogravimetry, wherein the signal is the mass of an electrodeposit on the cathode or anode in the electrochemical cell. And lastly, precipitation gravimetry, in which the signal is the mass of a resulting precipitate after the addition of a precipitating agent. We won't be focusing on all the types. The first two types are a bit simple to understand. The third one is more complex and we will not be discussing that. For the next slides, we will just focus our attention on precipitation gravimetry. Precipitation gravimetry is based on the formation of an insoluble compound following the addition of a precipitating agent or precipitant to a solution of the analyte. In most cases, reactions are double displacement reactions, aka metathesis reactions. However, any reaction that produces a solid can potentially be classified under here. So for the procedure, just an overview. First, the analyte is dissolved in the sample solution. You will start with a sample that is most probably homogeneous and that contains a lot of other substances. So there is no physical means of directly separating and quantifying your analyte. Number 2, precipitating agent is added to react with the analyte. Ideally, a gravimetric precipitating agent should react specifically or selectively with the analyte. Kung magre-react siya with other substances in the solution, then the stoichiometric calculations will not be reliable anymore. Number 3, precipitate of a known composition is produced. This is filtered and washed free of impurities. If it is not pure, then an additional treatment with heat or chemicals will be performed. In this step, maganda kung ang precipitate na na-form ay unreactive and stable and has really low solubility para maganda ang yield. In this step, there is a lot of potential loss of analyte kung hindi makollect lahat ng product. And again, if hindi maganda ang precipitate in terms of stability or the composition, then it can be treated with heat before it is weighed. Number 4, precipitate is dried and weighed. This is to ensure na walang water or solvent na kasama sa pag-measure ng mass because this is related to the next step. Number 5, stoichiometry, or a shortcut which is gravimetric factor, will be used to calculate the amount of the analyte in the starting solution. Kung may water or impurities na kasama ang precipitate na na-collect mo from the reaction, the result of this calculation will of course become inaccurate, especially if the water is not accounted for in the chemical equation. So we will be browsing through a list of analytes and their commonly used precipitating agents, aka precipitants. This table here is for cations. Next table is for anions. This one is for ions using organic precipitating reagents. This one is for analytes that are organic compounds. Now let's try solving a gravimetry problem. This is in particular a precipitation gravimetry problem. Example, the calcium in a 200 ml sample of natural water was determined by precipitating the cation as calcium oxalate. The precipitate was filtered, washed, and ignited in a crucible with an empty mass of 26.6002 grams. The mass of the crucible plus calcium oxide was 26.7134 grams. Calculate the concentration of calcium in water in units of grams per 100 ml of the water. So in the problem, it also states the molar weight of calcium oxide and calcium. Now it's easy to get overwhelmed with all the details. So let's summarize them in a table. Whatever is being determined is the analyte. So we write calcium under analyte. The value is unknown, and as you can read in the last sentence, we need to calculate the concentration of it in gram per 100 ml of water from the sample. Basically, it is just percent weight per volume, so we also wrote that down in the table. Next, the sample is water. The volume is 200.0 ml as in the given. Next, the precipitate from the reaction is calcium oxalate. but no mass of the precipitate is given, and you will soon realize that it is not so important because dumaan pa sa heat treatment ang precipitate. So the mass that is ended up getting measured is that of calcium oxide. So ilalagay natin siya dito sa post-treatment row. The weight is the mass of the calcium oxide plus the crucible minus the mass of the empty crucible, and that gave us 0.1132 grams. Now, to get the grams of calcium from the grams of calcium oxide, let us take out this grid. Then, let's fill it out. Given yung mass ng calcium oxide, so let's just write it there. Then, we must convert it to moles using the molar weight. And then, the mole ratio of calcium and calcium oxide. So to get the mole ratio, you can simply ask yourself, how many moles of calcium are there for every mole of calcium oxide? So it is obvious, no, that for every 1 mole of calcium oxide, meron tayong 1 mole of calcium. Then next, we also input the molar weight of calcium here. Then solve for the mass of calcium in the sample. Cancel out muna natin yung units. Okay, and this is the mass of calcium. But since the final answer asks us to give the concentration na grams per 100 ml sample, so this is the answer. So you simply divided the grams of calcium by 2. Okay, now I will just introduce you to a new term. So let's consider the equation that we set up earlier. If for example, you are analyzing multiple samples and these require solving for the calcium content, siguro naman ayaw nyo paulit-ulit yung pag-set up ng ganitong equation. So, chemists have this shortcut na kung saan they combine all the constants into one term and they call it the gravimetric factor. We will be discussing gravimetric factor in the further slides, so just remember the term. But for now, let's try another problem. An iron ore was analyzed by dissolving a 1.1324 gram sample in concentrated HCl. The resulting solution was diluted with water and the iron 3 was precipitated as a ferric oxide hydrate by the addition of ammonia. After filtration and washing, the residue was ignited at a high temperature to give 0.5394 grams of pure Fe2O3 or ferric oxide. Calculate A, the percent iron, and B, the percent Fe3O4 in the sample. Again, let's organize the important data from this problem. So the sample is an iron ore. The mass is as shown. And I also enumerated here the constituents of iron ore, particularly Fe2O3 and FeO. Recall that these are from the two oxidation states of iron, which is Fe3+ and Fe2+. In nature, they always occur together. So it is assumed both Fe2O3 and FeO are present. These are called ferric oxide and ferrous oxide respectively. Next, the precipitate. It is the hydrate of iron 3 oxide, but that is not important in this problem as well because dumaan ito sa heat post-treatment. And the resulting mass that is measured is that of Fe2O3. Post-treatment, the analysts were able to narrow it down to one form of iron. It is purely iron 3. Now, sabi dito, we are supposed to calculate for two things. Percent Fe and percent Fe3O4. In B, so just to clarify, Fe3O4 is just a mixture of Fe2O3 and FeO. So basically, ang gusto lang natin malaman sa B ay total iron oxide from the ore in percent. So, sige, let's solve for A, the percent of iron in the iron ore. And let's use the grid to find the mass of iron first. So, gagamitin natin ang mass ng Fe2O3. So, followed by the molar mass of Fe2O3, followed by the ratio of the moles. So, for the mole ratio, because there are 2 moles of iron per 1 mole of Fe2O4, we write it as such. And it is helpful if you look at the subscripts. Then lastly, we input the molar mass of Fe. So for the mass of Fe, we get this value, 0.37727 grams. This is not the final answer yet. We still have to compute for the percent iron of the sample. So, to solve for percent Fe in the sample, we simply divide the mass of Fe by the mass of the sample. Then, times 100. So, you get 33.32% Fe. Okay, next, letter B. We will now be computing for the percent Fe3O4. Parts of the grid from the previous question is going to be intact. Same lang yung nilagay natin na mass of Fe2O3 and yung molar mass niya. However, the mole ratio will be different. You can think of the balanced equation as something like this. And using the coefficients, we are going to use 2 mole Fe3O4 and 3 mole Fe2O3. But don't panic just yet. Kasi meron tayong shortcut na i-discuss later kung hindi nyo alam yung chemical equation. Moving on, we will use the molar mass of Fe3O4 to get this. And applying the same formula previously to get the percent, we get 46.04% Fe3O4 as the final answer. As mentioned earlier, we will be talking more about this gravimetric factor. Gravimetric factors are useful shortcuts kasi you will not have to make the grid every single time if paulit-ulit lang naman yung conversion na gagawin mo. The formula of the gravimetric factor is, like I said kanina, a combination of constants. So, it is also expressed in this equation right here, where A and B are the stoichiometric coefficients or the mole ratios, and in the numerator is the formula weight of the substance required or sought, and in the denominator is the formula weight of the substance weighed. Kung itong gravimetric factor na to imumultiply doon sa mass ng substance weighed, the result is the mass of the sought for substance. So, in short, you don't have to go through the grid if you use the gravimetric factor. Sometimes, you don't need to know the whole chemical equation to get the gravimetric factor. You just have to know the substance you're analyzing and the substance you are weighing. You simply just need to identify the element of interest. For example, yung substance weighed is lead 2 chromate or PbCrO4. The substance sought is chromium 3 oxide or Cr2O3. The element of interest is of course found in both chemical formulas. So, tanggal na agad si lead. Kasi hindi siya nakita sa substance sought. If there are two similar elements, usually it is not oxygen or a spectator ion. So in this case, the element of interest is most likely chromium. Okay, we just highlight it there. Now we've identified the element of interest. I think now we can identify the stoichiometric ratio. So, balikan natin ang formula ng gravimetric factor. Ano kaya yung i-input nating multiplier? Okay, in Cr2O3, there are two equivalents of chromium, while in PbCrO4, isang chromium lang. So, if you imagine them being in a chemical equation, bibigyan mo ng 2 na coefficient, si PbCrO4, para maging balance, right? Okay, so let's just take those coefficients and plug it in the equation. Okay, after that, we just plug in the values for the formula weight of Cr2O3 and formula weight of PbCrO4, and we get the gravimetric factor, 0.23514. So, if you are given the mass of PbCrO4, i-multiply nyo lang agad ang 0.23514 na gravimetric factor, then you will automatically get the mass of Cr2O3. So, that is the shortcut if you use gravimetric factor. So, just to summarize in this video, we discussed the definition of gravimetric analysis, also the types of gravimetric analyses. We focused on precipitation gravimetry and some calculations, and we also talked about the gravimetric factor. So that is all for this video. Thank you for listening.